In this video, we are going to talk about solving logarithmic equations. All right, so the first example is log base 6 of 5x plus 4 equals 5. All right, so we want to solve this equation for x, and if you recall, going back to the videos where we were solving for exponential equations, right, what we were doing was we were converting between the logarithmic form and the exponential form. Right, so the logarithmic form is y equals log base b of x, right? And that is exactly the same as saying b to the y equals x. So these two expressions, right, say exactly the same thing. They just say it in slightly different forms, okay? And if you haven't watched the videos where we first talk about this and converting back and forth, you probably need to go back and watch those videos and practice converting back and forth to get used to that, okay? So you can see that if I take a look at this equation, right, it involves a log, and so it looks very, very similar to this one right here. And in fact, it's exactly in the same format, all right? So we're going to just take this equation and switch it over to this format here. All right, and so that the base in this particular log, which is the base is normally the part that I focus on first, right? So the base in this log is going to be 6. You can see that becomes the base of the exponential function in the exponential form. So the base is going to be 6, right? Then what the log is equal to, right, which is a 5 in this case, becomes the exponent, right, over in the exponential form. So in this case, the log is equal to the 5. That's going to be the base on, or the exponent, right, on the base of 6. And then what is inside the logarithmic function, the argument of the logarithmic function, becomes goes by itself on the other side of the exponential expression in the exponential form. All right, so in that case, that's going to be 5x plus 4. Okay. All right, and so now you can see that this is pretty much just a regular equation that we are used to solving. We need to get 6 to the 5th power. All right, so that's going to be 7,776. And that's equal to 5x plus 4. So we are just simplifying both sides of the equation here. And then we would subtract 4 from both sides. And then finally divide both sides by 5. All right, so our answer here is going to be x equals 7,772 divided by 5. Okay. All right, next example. Okay, so in this example, we have log base, our log of x, and right there is no base written with the log, so that is an understood 10, right? That's called the common log. Okay, and we want to solve this equation. So again, what we are going to do, right, is to use the conversion from logarithmic form to exponential form. Okay, to solve this equation. All right, the one issue though, right, is when you look at this equation, it again doesn't match this equation very well, right? This, in order to use this conversion, it needs to be log base b of x, a single log over here, equals to some expression, and that's not what I have at all. I have these two logs being subtracted from one another, okay, equaling a number. So what you need to do if you have multiple logs in your problem is to rewrite those as a single logarithm, okay? So, and how you do that is by the properties of logs. So those three properties that we talked about, we called them the products rule for logs. We called it the quotient rule for log. The second one, the quotient rule for logs, and the third one, the power rule for logs. And so the one that we are using here is the quotient rule for logs, okay? So the quotient rule for logs says that, hey, if I have the log of a fraction, right, then what I can do is to rewrite that as the log of the top minus the log of the bottom, okay? What we want to do is kind of go the backwards way. We can write the subtraction of two logs, right, using that same rule, if we go from right to left, right, as log of the top divided by the log of the bottom, right? So the quotient rule looks like this, right? It says log base b of x over y is log base b of x minus log base b of y, right? So in a previous video we talked about those three rules, so that's the rule that we're using. We have the log base b of something minus the log base b of something else. That's what we had here, and so we are rewriting that as a fraction, okay? And that is very, very helpful because it makes it so that now if you take a look at this equation that we have, it matches this format exactly. Something equals log base b of something else, okay? And so now that it's in this form written as a single log, we can switch using this conversion, right, that we've been talking about all along when we've been talking about logarithmic functions. All right, so again, I normally focus on the base of the logarithm, right, in the logarithmic form becomes the base of the exponential function in the exponential form. In here, right, there is no base, so that is understood to be a 10, right? All right, next up, I usually focus on the exponent, right? And what the log is equal to on the other side of the log, which in this case is a 2, right? That becomes the exponent that goes on the base in the exponential form. So we're going to have a 2 here, right? That 2 is like the y. The y becomes the exponent over here. So it's going to be 10 squared. And then what is inside the log in the logarithmic form becomes goes on the opposite side of the exponential form in the exponential form. The opposite side of the exponential function, I should say. All right, so that's going to be x over 3. All right. And that is it as far as the conversion. And so now you can see all the logs are gone. We can just solve this like we've been solving the other equations in our class. So the first step would be to simplify everything on both sides. So 10 squared is 100. Each side is as simple as I can get it. So then I would add or subtract to get all the x terms on one side, all the non-x terms on the other side. And I don't need to do that, right? It's already done. And so then all I would need to do to get x by itself is to get rid of this 3 that x is being divided by. The easiest way to do that is just to multiply both sides by 3. So over on the left side I get 300. On the right side I get x. And so x equals 300. When you are solving these logarithmic equations, right, not this particular kind, but later on, you will need to be careful about, sometimes you will get fake solutions when you use these properties. They'll kind of creep in there, and so you will always have to check your answer. One of the easiest ways to check is just to make sure that when you plug this back in for x into the original equation, that you don't get a negative number inside of the log. In this case, we don't, right? So if I plug a 300 in there, I get log 300 minus log 3. You can even go check that on your calculator, right? Just to see that works. So if I did log 300 minus log 3, you'll see that I get exactly 2. Sometimes it seems you might get something that's not exact, but it should be very, very close, right, to very, very close, right, to the 2, if it's not exactly 2 in your calculator. Sometimes there's some error, it seems, round off error in there. All right, next example. Yeah, okay. All right, and so the general steps, right, for solving a logarithmic equation are to get all of the log terms on one side of the equation. We haven't had one where we've done that yet. So far, the two examples have been where all the log terms are on one side of the equation. And so you would do that and just add or subtract, right, to get the all the log terms on one side and all the non-log terms on the other side. And then you will use those three properties, right, for some of those three properties, right, the product rule, the quotient rule, or the power rule, to rewrite the logs as a single log, just like we did, right, in the previous example. All right, then rewrite the log in the exponential form. So that should get rid of the logs. And then you solve for x. Again, when you do this part here where you rewrite the logs as a single log and use the product, quotient, and power rule for logs, sometimes you will get false solutions even if you did everything perfectly. So you will have to check your answers to make sure that none of the answers make the inside of one of the logs in the original equation equal to negative. So just plug those x's back in to the original and just double check that. We really didn't have to do that in any of the previous examples, but we will definitely be doing that in the examples that we are going to take a look at next. Those examples are going to be moved to a separate video or separate videos.